Hey folks, since in the last session what we have done is, we have understood the high level overview of all the frequent used algorithms of natural language processing. So in this session our fun challenge is all about, let's try to find the TF-IDF scores of entire data. Again, in the previous session, along with that we have also implemented something known as TF-IDF on top of data that we have. That's what we have done. So in this session, first and foremost, real world problem statement is all about, let's try to find the TF-IDF scores of the entire data that we have. Let's try to find that. So if I will say, again, we have an object often as TF-IDF, and let me just execute. You will see this is the object of TF-IDF vectorizer class. Now using this TF-IDF, if I need all the feature names, I can think of calling something known as get_feature names. Cool. Let me just execute this line of code. Now you will see these are typically all the feature names that we have. Now let's try to compute its length. So I will say, hey, what is the length of the list that we have? Let's call length function C. We have 11.7 k data points, 11.7 key features that we have. Similarly, if I will say using TF-IDF, what is the TF-IDF score of each of the feature that we have over here? What is the TF-IDF score of that? So I can think of calling an inbuilt property or inbuilt attribute often known as IDF underscore. Let me execute this line of code. Now you will get an error representation of all the TF-IDF scores of all the features that you have. It means we have total 10k data points, and just to represent these 10k data points, we have 11,733 total features just to represent these 10k data points. It means this 11,733, or you can say as 11.7k features, just to represent your observations, you have probably 11.7k features. It means these 11.7k features have some scores just to represent it. So this is basically the error representation. This is basically the error representation of all the 11.7k features having some TF-IDF scores. Now, just to make things more clear, what you can do is you can say, hey, let's say I have some feature F1, let's say I have some feature F2, let's say I have some feature F3. Hey, can you tell what is the TF-IDF score of F1? What is the TF-IDF score of F2? What is the TF-IDF score of F3? Hey, can you find all that stuff? So let's try to code up all that stuff. So what I will do is I will say, hey, first and foremost, let's try to compute its length just to cross check all that stuff. So I will say, hey, what is the length of the array that you have? Cool. Now you will see your length is similar as what is the number of features that you have. Again, you can think of visualizing as, let's say you have feature 1 and let's say you have some value, let's say 0.6. So this is often known as dictionary, because it is nothing but a key value. And in a nutshell, dictionary is all about a key value pair. So let's try to create a dictionary of all the features along with the TF-IDF scores that you have. Let's try to create a dictionary. So I will say first and foremost, I have to combine this one, and along with that, I have to combine this one. First and foremost, I have to do that. So using zip, you can combine that. So I will say first and foremost, I need all the features. So I will say first and foremost, I need feature. Then I need their TF-IDF scores as well. So I can think as I need their TF-IDF scores. Cool. Now, the moment I will execute, you will see you will end up getting a zip object at some particular location. On top of this, if I will call a dictionary data structure, the moment I will execute this line of code, you will see with respect to some features, you will end up getting such an amazing TF-IDF scores. The moment I will scroll it to below, let me show you some other feature. Let's say 3 hours. It means wherever this 3 hours is available, this is exactly the TF-IDF value with respect to 3 hours that you have. This is what it stands for. Now you will see, if you have, let's say able, this is typically the TF-IDF score. Now let's try to store this dictionary somewhere else. Imagine word to TF-IDF. Imagine this is the dictionary name that we have, and let's execute, or let's print it. Cool. And this is the dictionary that you have. And just to access some key, I will say, hey, what is the TF-IDF score where my key is able? The moment I will execute, you will see you will end up getting some TF-IDF score. So the next problem statement is all about, we have to find the TF-IDF scores of the question that we have. Now let's try to pick some sample. So I will say, let's say data of question 1, let's say some index, let's say 0th index. Now we need to find the TF-IDF scores of each of the word of this question. This is typically the main goal. So what I will do is first and foremost, I need to access each and every word from this question. So I will say, hey, for word in this question. Cool. This is how you can think of accessing each and every word. Now we need to just initialize this word TF-IDF, which is of course our dictionary. Over here we have to pass this word. So I will say str of word. Again, str of word basically means, just to make sure, whatever word we have that must belong to something known as string nature. That's why just to call a string on top of that makes a lot of sense. So I will say it will return some IDF value, or it will return, let's say, some TF_IDF value. Cool. Now whatever it will return, hey, can you print that? So I will say I have some placeholder. Then again I have some placeholder, and I can receive its value from my format function. I will say dot format. So first is all about, let's say word, and the second is nothing but our TF_IDF. Cool. Now the moment I will execute this line of code, it gets executed, and unfortunately you will end up getting a key error as W. So just to handle this scenario, you can think of something known as exception handling. So I will say I have to just implement this exception handling using our try except block. I will say, cool, just use something known as try except block. It means the moment, let's say I have some code of lines over here. It means the moment if this block of code will return some kind of error. So just to handle this error, you have to write some lines of code in your except block. That is what, in a nutshell, our exception handling stands for. That's what it stands for. Now let's try to implement all this stuff, of course, using Python. So what I will do is I will say, hey, this is the actual line of code that we have, but the moment it will return some kind of error, I can think of using something known as except. Cool. So in such case, I can say, hey, just return 0 in my TF-IDF. So I will say TF_IDF. Cool. The moment I will again execute this line of code, now you will get a surprising result. All the values are 0. But here comes an interesting thing. These values are basically with respect to the characters that you have. This is not with respect to the word, because over here we are just iterating on top of the string that we have. Hence this word will typically point to the character. So what I can think is, I can say, hey, can I convert this into something known as list data structure, so that if I will iterate, we will end up getting some word. Let's try to do that. So I will say dot split. The moment I will call split, having some space as a separator, it will return a list data structure. Let me show that. If I will say this, let's execute. This is a list representation of the string that you have. And the moment I will execute this line of code, congratulations, this is the TF-IDF score that we have. It says, hey, if you have the word what, this is the TF-IDF score that you have. If you have the word is, this is the TF-IDF score that you have. Similarly, with respect to each of the word, you will end up getting some TF-IDF scores. So that's all about the session. Again, for those of you who have any doubt, feel free to ask with us in the Q&A of the course. That's all about it. Thank you. Have a nice day. Keep learning, keep growing, keep practicing.